Well, hello again. We are going to take a look at the double angle formulas in this little video today. First, I would like to just go through the rather simple process of deriving or constructing these double angle formulas, and then we'll use them in a couple of situations. And you'll see that they're pretty simple to use. They have a couple of pitfalls that I want to try to make you aware of, but otherwise they're pretty simple once you kind of get the hang of it. So first off, these formulas come from our angle addition formulas that we've been studying a little bit lately, and namely the sine angle addition formula, the cosine angle addition formula, and the tangent angle addition formula. So all of these double angle formulas come as a direct result of these formulas. And I'm going to focus first on the cosine angle addition rule. And the question here that I want to pose to you is that instead of saying cosine of A plus B, what if I took two angles and added them, what if I took one angle and added it to itself? In other words, instead of saying A plus B, I said something like theta plus theta. So if we had that, if we took cosine of theta plus theta, all right? And if you thought about that for just a second, I'm sure you would come to the conclusion that theta plus theta is the same thing as 2 theta. So when I say cosine of theta plus theta, really what I'm doing is thinking of cosine of 2 theta. So here's double the angle. All right, so that's what these formulas really are based on. So if you went back and looked at these angle addition formulas here and just replaced in each one of them A plus B, replaced it with theta plus theta, this is how we get to these angle addition formulas. So let's look at it for cosine first. And when you expand out the angle addition formula for cosine, you have cosine, cosine, sine, sine. Cosine theta minus sine theta. Well, it's pretty easy to see that cosine theta times cosine theta is equal to cosine squared theta. And same with the sine. Sine times sine is sine squared. And in fact, right there, we've just done it. That's the cosine double angle formula right there. Cosine of 2 theta is equal to, well, let me try that again. Cosine of 2 theta is equal to cosine squared theta minus sine squared. Now, there's something kind of interesting, and this is why I picked this one first to talk about. Cosine squared has its own little substitution possibility, and the same with the sine squared. It has its own substitution possibility based on our basic Pythagorean identity, cosine squared plus sine squared equals 1. All right? This identity, this fundamental Pythagorean identity, offers us these two possibilities. Let me write them down here. Cosine, of course, is equal to, that is, cosine squared is equal to 1 minus sine squared. And on the same token here, sine squared theta is equal to 1 minus cosine squared theta. So these two values here, 1 minus cosine squared theta in for sine squared, and 1 minus sine squared theta in for cosine, give us these possibilities of changing this double angle formula here with these two values. So let me write those out here for you on the next screen. So here's our double angle formula for cosine. Cosine 2 theta equals cosine squared minus sine squared. And if I go ahead and replace the cosine squared with 1 minus sine squared theta, look what I get. I get a brand new formula. Cosine of 2 theta equals 1 minus sine squared, which is just 1 minus 2 sine squared theta. So there's the first of two alternative formulas for the cosine double angle. So next, if I look again, have my basic angle, double angle formula for cosine there, and this time I replace sine squared with this 1 minus cosine squared theta. look what I get here. By cosine squared theta minus 1 minus cosine squared theta, probably a good idea to think of that in parentheses there. And you can see that subtracting the negative cosine is going to be the same as adding cosine squared. So what I wind up with as my other alternative formula for double angle is 2 cosine squared theta minus 1. And that's the other one. So cosine double angle formula is a little bit special in that it actually has 3 different versions. You have your basic one here, cosine squared minus sine squared, but then you also have these other 2 versions here. One of them only uses the sine function, and the other one only uses the cosine function. So they have a little advantage there that you don't need to use as much information to use these alternative versions. So if we kind of apply that same logic to the sine angle addition formula, that is, replace the a and b with theta and theta. So in other words, we're just adding an angle to itself. You can easily see that that is the same thing as saying sine of 2 theta. And when you expand that out to sine theta cosine theta plus cosine theta sine theta, well, what you'll notice, if pretty quickly I'm assuming, is that sine theta times cosine is the same thing as cosine times sine. That multiplication is a commutative property. So we have this then, sine of 2 theta is equal to 2 sine theta cosine theta. And that's the double angle formula for sine. It's pretty easy. So we'll take a look at the tangent formula here, and we'll get to it basically in the same way. So when we look at the tangent angle addition formula, tangent of theta plus theta, well, that clearly is tangent of 2 theta. And when we expand that angle addition formula out, tangent theta plus tangent theta over 1 minus tangent theta, we can see then that our double angle formula for tangent is 2 tangent theta. That's what tangent theta plus tangent theta equals, over 1 minus tangent squared. So that's it. There's our 3 double angle formulas. Well, I guess I should make that 5 because there's 2 extra ones for cosine. And so now we'll take a look at using them. And actually what I think I'll do, since we're already at about 7.5 minutes, I think I'll stop here and we'll do some examples on using these double angle formulas in another short video. Thank you. See you then.